Hi guys. As I told you before in the message on the Google Classroom today, that I would be talking about bonding. Bonding was the end of our chemistry unit, and I know that I spoke with you a little bit about ionic bond formation, and I also needed to talk to you about covalent bonding. You will review this stuff and go over this stuff again, definitely in grade 10 because it's part of the grade 10 curriculum, but I felt that you should be given the opportunity to have exposure to this before grade 10. So I'm just going to go through with the two different types of bonding with you. And today I'm going to go over ionic bonding. And so as we talked about before this whole craziness started, we talked about the atom, the atomic structure. We talked about how atoms become ions by losing or gaining electrons, which basically they become negatively charged or positively charged atoms. And we also talked a little bit about why atoms lose or gain electrons. And basically we know now that atoms will gain or lose electrons so that they have a stable configuration of electrons in their outermost energy level or their valence level. Okay, so the reactivity of elements is basically influenced by the arrangement of their valence electrons. Okay, and they do this, they react in order to gain stability. So, and the most stable elements, as you know, are the noble gases, which are the group 8 elements on that periodic table. And they have a full outer valence shell. And this is known as a stable octet, or in the case of helium and hydrogen, this is known as a stable duet, which is basically a maximum of 2 valence electrons in the outermost energy level, as opposed to the stable octet, which is the maximum of 8 electrons in the outermost valence shell. Okay, so we know that atoms will undergo chemical reactions and bond with each other in order to gain that stability, gain their stable octets or duets. So the basics of ionic bond formation. So ionic bonds are basically chemical bonds where there are compounds formed when a metal and a non-metal atom react together. So the metals are on the left side of the periodic table, and the non-metals are on the right side of the periodic table, and they get together to form an ionic bond and basically an ionic compound. Okay, so usually there is, not usually, ionic bond formation involves a transfer of electrons from the metal atoms, which usually have an excess of electrons that they need to get rid of, to non-metal atoms, which usually are in need of electrons. So metals, therefore, tend to form positively charged ions, whereas non-metals tend to form negatively charged ions. And when the atoms within the chemical bond become ions, when they come together because of the attraction between the negatively charged and the positively charged ions, the entire compound, the new compound that is formed, is electrically neutral in. So I talked to you about in class the sodium and the chlorine. These are two atoms that, or elements that are very, very reactive, and they're reactive because they are unstable. Sodium has one lone electron in its valence shell, whereas chlorine has 7 electrons in the valence shell, making it very reactive. It needs to have one more electron to make it stable and happy, and sodium needs to get rid of that electron to make it very stable and happy. So when it gets rid of this electron and transfers it to chlorine, sodium will have 1, 2, 3, 4, 5, 6, 7, 8 electrons in the outermost energy level, and chlorine will also have 1, 2, 3, 4, 5, 6, 7, 8 electrons in the outermost energy level. Okay, and this right here is what an ionic bond actually looks like. So you have the sodium, which is now an ion because it has lost, it's a positively charged ion, it has lost the electron, and chlorine is a negatively charged ion with a charge of -1 because it's gained that extra negatively charged particle there. So it is the attraction, the electrostatic attraction, which holds the ions together, and this is what is called the bond. So right here we have a ionic compound of salt, okay, and this is before you have the compound, before you have the attraction between the ions, you have to have the transfer of the electrons, and that is the example of sodium and chlorine as they get together. That's the reaction that takes place, and we have the product is called sodium chloride. In addition to the bond formation, I wanted to talk a little bit about the properties of ionic compounds. So physical state of ionic compounds, mostly they exist as solids because of the solid arrangement that they exist in. It's called a lattice, crystal lattice, which is basically a regular repeating pattern of ions. And then the bonds between those ions are very, very strong, so that ionic compounds usually have very high melting and boiling points. Ionic compounds are usually very soluble in water. They dissolve because basically the water molecules can separate the positive and the negative ions from each other, breaking those ionic bonds. So let me just see if I can make this a little, I guess I can't. Oops. So as you can see in this picture, the molecules here, the red and the two white balls here represent the water molecules, and the green circles represent the chlorine ions, which are negatively charged, and the little blue circles with the plus sign represent the sodium ions. And basically what happens is that the positively charged hydrogen ions of the water molecule will be attracted to the negatively charged chloride ions of that ionic compound. So when you have that attraction, you're going to separate the chloride ions from the sodium ions, and basically all the ions are going to be surrounded by these water molecules. You see over here that the lone chloride ion is being attracted by the hydrogen ions, which are positively charged, and the oxygen atoms of that water molecule are facing the opposite direction of the chloride ion, and the hydrogen atoms are facing the negatively charged chloride ion, okay, because of the attraction. Opposites attract. And so this is the crystal lattice structure, which is slowly being dissolved in the water by the water molecules, but this is what the salt actually looks like, solid structure before it starts to dissolve in the water. Conductivity is also another factor that we need to look at in terms of ionic compounds. They are very good conductors of electricity, but only when they are like this in the dissolved form. So when you put your conductivity indicator or meter in a sample of salt, there would be no conductivity. But if you put that same conductivity meter or indicator into salt water, you would see the light bulb go on, because they are that solution is very conductive. So they're not good conductors in the solid state because they're locked into that crystal lattice structure. And as we see down here, the sodium chloride crystal structure, that's what it looks like. And then as we place the crystal structure into water, again, the water molecules surround each of the ions in a different way, mind you. So again, the hydrogen atoms are facing the negatively charged chloride ion, and the negatively charged oxygen atoms are facing the positively charged sodium ions. And that's how water separates the sodium chloride into the ions. The salt, even though it's dissolved, it's still there. And if you remove the water by evaporation, you would get this solid crystalline structure again, because they would start to come together because of the force of attraction between those oppositely charged ions.